Hello, I'm here to talk to you a little bit about our system for automatic projector calibration. The basic problem we're trying to solve is the task of trying to fit a projected image perfectly onto a target surface such as this. Typically, that requires the screen to be directly in front of the projector and at a very specific orientation to get an undistorted image. But what we would like to do is be able to place the screen in any location that's convenient and then calibrate the projector onto the target surface. To demonstrate our system, I have an unmodified projector, a computer beneath the table, and this target surface. If I turn this surface over, you can see that we've implemented it with some electronics. What we have here are optical fibers that channel light energy from each corner of the screen to an electronics package containing 4 optical sensors and a USB connection to the PC. When I turn the screen back over, you can see that there is no visual evidence of the fibers. The white surface acts to hide the fibers and also provides a light diffuser which improves calibration reliability. To calibrate onto the target, I can simply place it in the projection area and then project a series of grade-coded binary patterns. These patterns uniquely identify every pixel in the projection screen, allowing us to discover the location of each fiber. We can then use this information to project a corrected image. Here in this close-up, you can see that the quality of calibration is very high. The discovered location of each fiber is actually closest to the nearest pixel. The prototype shown here is capable of performing a calibration in just over 1 second. We're currently working on techniques that will hopefully allow us to achieve interactive rates. Here's what the calibration process looks like from the perspective of the target. You can see the irregular flashing from the projector. This pattern of flashes indicates the location of the camera in the projector screen space. To illustrate the robustness of this technique, we will gradually decrease the projection angle of the calibration. We have found that the calibration continues to work reliably even when the projection angle is less than 2 degrees. In this last calibration, the screen is actually facing slightly away from the projector. The expansion of the projection frustum is sufficient for this technique to work. We can also fold the optical path using a mirror with no effect on the calibration process. The image will be automatically reversed since the orientation of the image is determined by the screen and not the projector. This wireframe test pattern that I've been using is mainly to make it easy to see the quality of calibration, but using OpenGL or DirectX, we can warp real-time video on low-cost commodity hardware. We also have an implementation that allows us to warp the active Windows desktop, creating a fully usable calibrated display. In this board, we have added a total of 6 sensors, 1 in each corner and 2 across the middle. This allows us to calibrate 2 projectors that are placed side by side, creating a method for automatically stitching multiple projectors. We calibrate each projector individually and then blend the 2 images together. Here we have 2 projectors displaying synchronized video which have been calibrated onto the same target. This is useful for touch screens by reducing the visual impact of shadows. 2 lesser shadows are created, but neither entirely occlude the projected content. This is also useful for aligning stereoscopic projection systems. Our last demonstration uses this toy car that has been implemented with 8 optical fibers. These registration points allow us to use the known geometry of the model to dynamically give the car a custom paint job and hubcap details. If the car is moved, we can realign the model to fit the new perspective in just a few seconds. This previously required a 15 to 20 minute manual realignment process. This close-up view of the car shows the accuracy of registration between the projected image and the physical features of the model. Our calibration system brings these ideas of appearance customization to a closer practical reality. This simple, robust technique for automatically calibrating projectors allows us to rethink the way we use projection technology and explore applications that may have been previously impossible or impractical.